Hello guys, I am KDVinit. I'm currently International Master on Codeforces. I'll be going through the editorial for Codeforces Global Round 21. I'll briefly go through the solutions for the problems A to E. So let's get started. So the first problem is NIT ORZ. Yeah. So what you're given is you have an array of n integers indexed from 1. So you have A1 to AN. And you also have an integer z, and the operation which you can do with the array is take an integer I between 1 and n and simultaneously set ai to ai or z and set z to ai and z. And your task is to figure out the maximum value in array A after any number of operations. So yeah, so the basic idea is to see that the number of bits uh, and the particular bits in Z would always turn off. So Z would always be set to AI and Z. So whenever you do the operation, either the bits in Z would remain the same or they would decrease. This is based on like how you define AND in the first place. So you can go through that if you're not clear with this. So the number of bits in Z would only be remain the same or decrease. And thus, when you do the OR operation, the bits of AI would either remain the same or they would increase when like they for some place where AI is 0 and like some bit where AI has 0 and Z has 1. So yeah, and since we have to figure out the maximum value in the array, uh, we must use the best where like our value of Z can't improve because its bit would only decrease. So what's optimal is to use Z only for the maximum element, like the element which would be maximum after using. So this like so basically, if you will just try out with a few examples, you can see that you will like what's optimal is to only use Z once. Because for the further elements, you would either be like you would always be using less optimal. So you only want to use the this operation once, and you will do it on the element which gives you the maximum element. I'll just show my solution. This is my solution. You take in the input n and z and the array, and for each element, you figure out what will be the OR of x and z, and your answer will be the maximum of all these values because you will be only doing this operation once. Okay. So that's the solution for A. We'll move on to the next problem. So the next problem is NIT destroys the universe. So you have been explained what is max of S, which is the smallest non-negative integer that does not appear in S for a set S. And yeah, you're given an array A1 to AN, and your task is to destroy A1 to AN. And one destroying A1, like destroying the array means for like somehow being able to make all the elements of the array equal to 0. And in one operation, what you can do is select L and R between 1 and n and set all elements from AL to AR equal to the max of the elements between AL to AR. So this is the operation you can do, and your task is to figure out the maximum number of operations that minimum number of operations that you would need to set all the values to 0. So to start with, what like you might think is like you would probably not want to do this operation on 0 because it's already set to 0. So you want to make all the non-zero elements equal to 0. And for that, what you can do is group all the non-zero elements. So maybe let's take an example. Yeah. Suppose we have this. Suppose we have this example. So you won't want to use the operation on 0 because you want to use the minimum number of operation. And probably what you can do is group all the non-zero elements together and do the operation on them. Because the max of all the max of a set of non-zero elements would be 0. And if your set contains even 1 0, your max would be non-zero. So you don't want to include 0 because you want to make the element 0. So what you can do is select all non-zero elements, group them like as much as you can, and put the do the operation on them. So you can do the one operation on this, one on this, one on this, one on this, and one on this. There is one particular way in which you can uh, uh, change the destroy the array. This is like one thing which I submitted first, which got a wrong answer. And after that, I realized that okay, there is one easier way. So if you do the operation on all the elements of the array, if it indeed contains a 0, then the max of all these elements would be a non-zero element. And so all of them would change to a non-zero element, after which you can do the operation on these elements again, and that will make all of them 0. So your answer should be either the one which we calculated previously or 0. And it can simply just be the best of both of them. So yeah. So what you do is you take an input as you take the array as input and you figure out the number of non-zero groups. You can simply do that by calculating non-zero elements which have a 0 before them. So that will calculate the number of groups of non-zero elements. And yeah, so this is basically just to calculate that. And your answer just would simply be the minimum of the answers you calculated or 2. You can always do it in 2 operations. That's the answer. I hope the solution is clear. We'll move on to the next problem, which is C. Fishingprince plays with arrays. Okay. This is in particular a nice problem for C in a global round. Yeah, we'll start with the problem. You're given an array. You're given 2 arrays, in fact, A and B. One has length n and B has length k. In one operation, you can take a particular element in A, which is divisible by m, and divide it into ai by m equal numbers without changing the order. Or you can do the reverse of it. You can select m equal integers and group them together. Your task is to eventually change the array A to array B. I hope the problem statement is clear. You can go to the problem statement in case it's still unclear. So yeah, you can try out a bit with a few examples to see what you would do. Like there are maybe multiple approaches. Like one easy approach which I could figure out during the contest is there's sort of a greedy technique. So suppose you again you have to go from A to B. So you would be dividing A or merging some elements in the set A, and you keep on doing it. Like you have divide and merge and so what you can probably do is, like suppose there is some way to make it from A to B, then um, there should also be a way to go from A to B when you divide A multiple times. Okay, I'll just explain with an example what I'm saying. So yeah, suppose A is 8, 4, 9, and m, which is the number which you can divide or merge, is 2. What I can probably do is do the operation on 8, which will make it 4, 4, then 4 and 9. And maybe then do it on this, which would make it 4, 4 and 9. And then maybe, let's say this was the array we wanted to make. This is our A, this is our B, and this is the operation we did. So what I claim is that if there is some way to go from A to B, then there should also be a way to go from A to B when you divide it completely, like as much as you can. So we can divide A into 449. Then we can divide 4 into 2. Yeah, first 4. Okay, this would be 4, 4, and 4 and 9. And this would be first 4 is being divided into 2 2s. And similarly, you can do for both the 4s. And yeah, and then you can again probably divide these 2s to form 1 1. These should be 12 ones and a 9. So this is the maximum you can divide to. And then you have to form this. This. You can also merge 2 elements. So you'll probably merge these 4 to make 4, then these 4 to make 4, and these 2 to make 2, these 2 to make 2, and then 9. So basically the claim is that you divide the array A as much as you can, and then you try to form B. Because if there was some way in between from which you could make B, you can always reach there by merging an element, by merging M elements together. So if there is some way to go from A to B, there should also be a way to go from the most divided version of A, from the most divided version of A to B. Because the elements of A can always be formed back again by merging M elements. So that is one thing. And yeah, and you can probably think about the same from B. So suppose there is some way to reach from this to B. Then okay, let's call this as the divided version of A. And now we want to reach from divided version of A, the most divided version, like the most division you can do to A, to B. And yeah, and now we claim that we can do this if and only if the most divided version of B is equal to most divided version of A. So we know that um, we know that in some way you have to reach from this to B. So suppose D of B is something. Yeah. So now we claim that you can reach from A to B if and only if the most divided version of A is equal to the most divided version of B. And this can be proved in both the directions. I'll probably omit it for the editorial right now. You can think a bit more on the same. I will go to the solution for now. If it's unclear that why that would hold, we can probably put it up in the comment and we'll try to give another explanation for the same. I'll just show the code for now. Yeah, so this is your array A, this is your array B. Yeah, this is you divide the element A by n as many times as you can and keep a count of how many elements are there. Yeah, and similarly you do for B. You divide the element B as many times as it can and you store the count of the elements. Suppose it's the element is 8 and M is 2. So you know that you can divide it 3 times. So the element which you would reach at the end would be 1. And you would have 8 copies of it. So you store both of these, the element and the number of copies you have for both A and B. And now what you do is you just try to figure out if both these divisions are the same. So they may not match exactly element by element, but when you arrange them in a line, they should be the same. So for that, you can see the implementation that I have done. There can be multiple implementation, but what I have done is I put pointers for both the arrays A and B, like the divided version of A and B, and now I iterate over them. So at any point, AI and BJ should be the same, and whenever they are same, I subtract the minimum count for both of them, and in case some of them turns to 0, we move ahead. Yeah, and if all the elements got were traced out in this manner, you print yes. If at some point one particular array got over, you print no. Or if at some particular point they were different, then you print no. So I hope that is clear. Uh, Maybe I will just give proof for one direction of how why this is like why this thing holds. So yeah. So suppose you know that d of A and d of B are same. Uh, then we can claim that it's possible to reach from A to B. So yeah. Uh, so since the divided versions are same, you know that you can reach from d of A to A, and you can reach from d of B to B. So what you can simply do is you start with A, keep on dividing it until you get d of A, and then you know that d of A and d of B are same. So this is same as d of B, and now you know that you can keep like there is some way of merging them that you reach B. It's like one direction of proof, but there's another direction. You can probably try it out. But I guess this intuition should be sufficient to implement the problem in the contest. Another possible way of doing this problem could be that you start with A and you find the most divided version of A, and then you just try to figure out if you can combine its element to form B. There is another way in which you can probably do this problem, but I thought might be that would be a bit more complicated to implement, and this would be a bit simpler. So yeah, we'll go on to the next problem, which is problem D. This is a bit interesting problem, and I think this is not that very difficult as well for D. So yeah, I think you should be probably be able to do it. So yeah, you have an array A consisting of n distinct integers from 1 to n. Basically, the array is a permutation. And yeah, you're given that you form undirected graph with the n vertices. And for every pair of integers I and j, if minimum of ij is ai and maximum of ij is aj, or the converse of this, uh, then you add a undirected edge of length 1 between I and j. And your task is to figure out the shortest path from vertex 1 to n in this undirected graph. It can always be shown that there is some path. So we'll start up with a few like some example. I guess this is how you probably start up with most of the problems in Codeforces. Probably we can start with this example. So this is your array, and you can see that if you select the like biggest array, which is like from 1 to n, this is the minimum and this is the maximum, and you know that you can like you have one edge over this, and so you can go from 1 to n by just using one edge. So the answer for the same is 1. Yeah. Now consider some different permutation which has like some elements, then it has 1, then it has some elements, then it has n, and then it has some element. Now note that if you select an j here and a I here, then the minimum of any array, subarray across 1 would be 1, and that would not be the first or last element. So there cannot be a edge across 1, and similarly there cannot be any edge across n. So if you have to go from 1 to n, you must first go till 1 and then go from 1 to n and then go from n to the n. So how you go from n to n can have different like multiple paths, and that can have multiple weights. So that might not be one like that might not be one exactly. And similarly, how you move from 1 to here can have multiple paths. But you can clearly see that the best way to go from 1 to n is just select 1 to n, because that would follow the condition, and you can go from there like 1 to n like these particular length in just one move. So that is like the best thing right here, right now. Then what you might think is like, I have to reach one from here. So what can be the possible ways? So from one, what all vertices would be able to reach one? So if we see that, yeah, so one, like you can reach one from any vertex from where the maximum is that particular one, that particular element itself. Because we know that the minimum of this array would be one, and since we want to have an edge from that particular vertex to one, the element at that particular index should be the maximum in this range. So so any vertex which is maximum, which is maximum from its position to one, can reach to one. And since we want to do it in the minimum number of moves, we want to take the element which is the furthest. So suppose you know that the biggest element, in this range is x. Then any element here won't work, because from here to 1, the maximum would be x, and some elements from the right of x might work or may not work. But we know that for sure that the leftmost element which would work has to be x, because any index after this won't work. So the leftmost element, or the best way to reach one from its left, is to take an edge from the maximum element in this range. And yeah, so you figure out the maximum element in this range and you go from here to one. And now we have to figure out how to reach this maximum element. So we know that since this is the maximum element of this particular prefix, then all the elements here should be less than it. So if we want to go from some element to here, then this would be the maximum element of that subarray. So the element we select should be the minimum element. And similarly, like by the same analogy that what we used, the best way to go from the left side is to select the minimum element in this range to go, which would be like some y. And you can keep on doing this until you reach the first vertex. And similarly, on the right side, you figure out the maximum element in this range, which would be n. Then you figure out the minimum element in this range, which is say z. And then you keep on going that until you reach the last element. I'll probably show the code for the same, which should make it a bit more clear. So you take in the input, you find the position. Maybe I'll just zoom it in a bit. Yeah. So you take input the array, you find the you store the position of each particular element. Then what you do is you you calculate the prefix maximum and the prefix minimum, and similarly you also calculate the suffix maximum and the suffix minimum. Now what you do is you initialize your answer with 0, and you initially start with 1, like the position of 1, and last is basically whether the last element was minimum element or the maximum element. So while we have not reached 1, what we do is we have to take one more step. And yeah, and if the last element was minimum element, then we calculate the max of the prefix and then directly reach over there, which is position of x, and then we change last to 1 because the last element was maximum element. And if the last element was not the minimum element, which is like last element of the maximum element, then we find the minimum of the prefix and go to there, which is what we discussed over here. Like from the left of 1, we first figure out the maximum in that range, then the minimum in that range, and keep on doing that until you reach the index 1. Yeah, that's what we do on the left side. And similarly, we do on the right side with the use of suffix maximum and suffix minimum. Maybe the solution looks a bit complicated, but if you just try it out with a few examples, it would feel pretty intuitive and pretty logical. Okay. That was problem D. Yeah, I'll probably not go over the solution of like the proof of for problem E, as that might be a bit complicated for the video. I'll just tell you a basic intuition based on which you can get the problem. So yeah, again in E, you are given an array which is like non-increasing, and you are defined some ways in which you color an infinite grid. So we'll just draw it. You have an infinite grid, and you have some elements. You have some elements which are colored white over here, and some elements equal to it or less than it which are colored white over here. Um, some elements which are colored white over here and some which are white over here. And this way you have like an infinite value after a point when it turns to 0. And you have like some like you have been defined that you have a doll on 0, 0. And then in each operation you can duplicate the doll towards its right, and like, you can remove this doll and put one doll instead on its right and on its left. And you can keep on you have to keep on doing that until there are no dolls on the white grid. Yeah. So you have to calculate the minimum of operation required to achieve this goal. And you have to print that output modulo 10.9%. Yeah, you can see that clearly to remove this particular doll from the first row, you should keep moving it to the right. The first move would be to take it from here and move it to the right. So there would be one doll over here and one doll over here. Then you would do the same here. So that would mean moving this. Now one doll over here and one doll over here. And again, you would do on this. So again, what we're trying is to move the doll out of the first row. Once it's out of the first row, it can't reach back to the first row. That's one nice thing. Yeah. So you keep on doing that until you have been like have bring the doll till here, and then you do, and then the doll is out of the grid, like out of the white part of the grid. And but in that, like meanwhile doing that, you have duplicated the doll to all the uh, cells in the second row. This took you exactly a of 1 or a of 0 moves. Yeah, you can just do that. Similarly, you can try to calculate the number of moves that you would require for A1 and A2. And you would probably see a pattern in that. So you can actually prove the same as well, but again, it's a bit complicated for the video. So we can figure out the pattern for the same. And yeah, so basically the pattern it follows is that the number of moves to remove the doll from the ith row is equals to n choose r ncr of ai plus I choose I plus 1. You can clearly see the same for I equal to 0 as we showed, which would be ai c1, which is ai, and we can similarly see it for all the subsequent moves. So that's what the solution for E is. You can again prove the same, but it might be a bit complicated for this video. So we'll just skip that. So yep, that's the solutions for all the problems from A to E. If you have any queries, please put it up in the comments and we can probably try to solve them up. Thank you.